set of factoring problems we just did were very different from the ones we're about to do in a key way, and that is that the ones we're about to do are now going to have a number in front. All of the factoring we just did had just plain old x squared. These are going to have, they're called leading coefficients. So, for example, 3x squared plus 31x plus 10 is an example of this type of problem. So the issue here is this polynomial starts with a 3, which wouldn't be that big of a deal if there was a greatest common factor of 3. If we could factor out a 3, we just have plain old x squared and we're in business. But this problem does not have a greatest common factor of 3. In fact, it doesn't have a greatest common factor at all. I'm going to teach you how to solve these types of factoring problems using a technique that is called factoring by grouping. I want you to really appreciate me teaching you factoring by grouping, by the way, because back when I was in algebra, back in the dark ages when the world was in black and white, my teacher taught us to solve these by doing a method that was not called factoring by grouping. It was called guess and check. That is not a joke. That is for real what it was called. Guess and check worked like this. You do your two parentheses. And our first term was 3x squared, which means I'd have to start with 3x and x, right? That's the only way to get 3x squared is 3x times x. The numbers on the end, though, would have to be multiples of 10. So the question is, what would the multiples of 10 be? It could be 1 and 10, or it could be 2 and 5. And since we've got a 3x and a 1x here, since these aren't the same, the order really, really matters. For example, let's say I decided to do 5 and 2 as my multiples of 10. Okay? I'm going to check this by doing the distributive property. 3x times x. 3x times 2 is 6x. 5 times x is 5x. And 5 times 2 is 10. This is 11x, and I wanted 31x. So that doesn't work. I wonder if it will work if I just switch the 2 and the 5. Now distribute again. 3x times x. 3x times 5. Notice I'm getting different numbers now just because I changed the order. 2 times x and 2 times 5. That adds up to 17x, and I wanted 31, so that doesn't work. Well, I guess I'll try a different pair of numbers, like 1 and 10, and if that doesn't work, I'll try 10 and 1.
I don't like the guess and check.
It's awesome if you like to do the distributive property a bajillion times. This one isn't even that bad. There would only be 4 combinations here. Imagine if instead of a 10, this was a 12. 12 could be 1 and 12, 2 and 6, or 3 and 4, plus the opposite order, 12 and 1, 6 and 2, 4 and 3. It's also really easy because that's a 3x squared. What if that in front was a 12x squared? This could be 4x and 3x, or 3x and 4x, or 6x and 2x, or 2x and 6x, or 12x and 1x. You get the idea. What if this was a negative 12? Now I got to do negative 4 and positive 3, positive 4 and negative 3, and the reverse order. It sounds like a whole lot of fun, I know, but surprisingly not a great way to solve these factoring problems. But if you want to practice distributive property, it's an outstanding way to do that. So instead, I'm going to teach you a method called factoring by grouping. Factoring by grouping sort of splits the difference with guess and check time-wise. What I mean by that is if you do the guess and check method and the combo you guess first is the right one, it's really, really fast. If you guess the right combination, you're done almost immediately. If you guess the wrong combination, it will take potentially the rest of your natural life to get the correct combination. Factoring by grouping takes a little bit longer than if you got guess and check right on your first go, but takes way less time than if you get guess and check right on your 27th go. It's a really good method that takes about the same amount of time. Now, the last factoring problems we did, we found values for B and values for C, and we're still going to do that. Only this time we've got a new number. The number in front of x squared, that's going to be a. So we have a, b, and c, and we're going to use all three of those numbers in this type of factoring problem. You only have to worry about a if there is a leading coefficient. If this is plain old x squared, we do it just like we did the last bunch. Okay? So here's the thing. The strategy is largely the same as just regular factoring without the leading coefficient, in that I want two numbers that will multiply together to give me this, but when I add them they will give me this. The difference is, instead of searching for factors of just c like I did last time, I'm searching for factors of a times c, which in this case is 3 times 10. I'm searching for factors of 30. Just like last time, I want factors of 30 that will add up to b, which is 31. Okay, what are two factors, any two factors you can think of, for 30? How about 1 times 30? 1 times 30 is 30. Okay, what about if I add them? 1 plus 30. Oh, you are so lucky. You got the right combination first thing. So the two numbers I want are 1 and 30. So here's where it gets a little goofy. I am going to take this polynomial we had here, 3x squared plus 31x plus 10, and this b right here in the middle, this 31, is going to get split. Instead of 31x, it's going to be split into two different things. And the two different things are going to be 1x and 30x. So instead of 31x, it's going to be 1x plus 30x. So the 3x squared stays the same. In the middle, instead of 31x, plus 1x plus 30x. And on the end, the 10 stays the same. I haven't actually changed anything about this problem technically, because if I were to combine my like terms here, if I were to put the 1x and the 30x back together, I just have 31x again. So all I did was take that middle term and split it into two pieces. And the way I knew which two pieces to split it into was by using the factors, okay? Now we're going to do what we did last week, which was group the factors together. First, I'm going to find the greatest common factor of these two things. So let's do that. What's the greatest common factor of 3x squared and x? X. Let's divide. 3x squared divided by x is 3x plus 1x divided by x is 1. Okay. Then I'm going to do the exact same thing with the second pair. What's the greatest common factor of 30x and 10? 10. Instead of 30x, I will now have 3x. And instead of plus 10, I will now have plus 1. That should look pretty familiar to you. When we did factoring by grouping last time, we ended up with two terms that had the same parentheses in each. So do you remember how to put this together to get our final answer?
3x plus 1 goes on the outside.
3x plus 1 on the outside of parentheses.
And then x plus 10.
And x plus 10 on the inside. Factoring by grouping, son. So I hope you practiced factoring by grouping a whole lot in this last week, because you're about to do a ton of it. I hope you're ready. I hope you're mentally and physically ready. I'm going to take that no as a yes. Those of you that did not come to class last week are now regretting the error of your ways. All right, great. What do I do first? Yeah, I look for a GCF. Is there a greatest common factor for 8, 14, and 5?
No.
No, there's not. Okay. So step number 2 is going to be to identify what the A, B, and C are. So what's A in this problem? A is 8. B is negative 14. And C is great. So what am I looking for factors of? 40. I'm looking for factors of A times C, which is 40. All right. Any two factors of 40? 2 times 20. Great.
What does their sum have to be?
Their sum has to be 14.
Or negative 14.
Right, negative 14. So 2 and 20 does not equal negative 14. Okay, give me another one.
Negative 2.
Negative 2 and negative 20? Because I still want to get positive 40 when I multiply them. Negative 2 plus negative 20 is negative 22. So we're closer because now we got a negative, but still not negative 14.
Times 5 is
7 times 5 is 35.
Or 8. We can't do 8 and 5?
We can. 8 times 5, that works. They have to be negative 8 and negative 5, right? We need two negatives. It'll be positive 40 when I multiply them. Negative 8 plus negative 5 is negative 13. So close. I need negative 14 and I have negative 13.
4 and negative 10.
How about negative 4 and negative 10?
Negative.
We need them to both be negative so that when we multiply them we get positive 40. Positive 40. Negative 4 plus negative 10 is negative 14. Oh my goodness. You cracked the code. Cool. So my numbers are negative 4 and negative 10. What do I do with that? Well, I take the negative 14x and I split it apart into two different terms, minus 4x minus 10x. So the 8x squared stays the same. Instead of negative 14, I have minus 4x minus 10x, and on the end, plus 5. Okay? Now we can actually factor by grouping. So let's take the first two. What is the greatest common factor of 8x squared and 4x? 4, that sounds good, but you're not getting greedy enough.
4x.
4x. So now we divide. 8x squared divided by 4x is 2x, good. Minus 4x divided by 4x is
1.
Great. Now let's look at the next two. What's the greatest common factor of negative 10x plus 5?
Negative.
It's -5. Remember what I told you last week? If it starts with a negative, you must factor out a negative. It starts with a -10. You must factor out a negative or you're going to have a bad time. So let's divide. What's -10x divided by -5?
2x.
Positive 2x. And then what's +5 divided by -5? -1. Oh, we're getting close. I can feel it.
Wait, why is the -5 in between the parentheses? Because the GCF
That's the-
That's the GCF.
-5 is the GCF of these two and goes out in front of the parentheses.
Oh, okay.
So what are the two parentheses in my answer? Well, they both have the 2x minus 1, so that goes out in front. What would be left in the parentheses?
4x minus 5.
-5. You are so smart. What a great answer. What a great bunch of algebra students. I'll bet your math teacher is so good that he can run the 100-meter dash in under 20 seconds. Okay, 25. Under 25 seconds. Well done. Very well done. We have not yet begun to ruin your evening, I'm sorry to say. That's only 2 problems. I know it took us 7.5 hours to do those 2 problems, but...
That's how long it'll take me without you sitting here.
Dude, confidence! Have some confidence! It's just like riding a bike. It takes practice, but after you learn how to do it, you will find there are far more things you'd rather do with your time. Okay. Step number 1. Huh?
The GCF.
Is there a GCF?
-2.
Yep, there is a GCF. You said -2. I'm not gonna do -2 because it doesn't start with a negative. I'm just gonna do 2. So 2 outside the parentheses. What would be left after I divided everything by 2? 3x squared minus x minus
10.
So good. So good. Now put a pin in this. Do not forget that we had a greatest common factor here because we're going to have that as part of our answer. Don't forget it. But now the question is, the thing that's left over in the parentheses, the 3x squared minus x minus 10, can that be factored some more? If it can, we need to factor it. And if it can't, this is the answer. This is the answer if what's in the parentheses won't factor. Okay?
Can you give us an example on the next one, how to do that? Or to show that, you know, if we can keep going?
Sure, yeah, well, I mean, you'll find out on this one. If you try to factor 3x squared minus x minus 10 and you find that you can't, it's a prime, for example, there aren't 2 numbers that will work, then that would just be the answer to the problem.
Okay.
GCF and you're done.
But do we still use the A thing? A times
You still use ABC to see if it will factor. But if it can't factor, you don't worry about it. Hey, speaking of, what's A?
3.
A is 3. B's a little tricky. What's B? -1. And C is -10. So I'm looking for factors of -30. 3 times -10, -30. All right, gang. Give me some factors of -30.
3 is it?
Hmm?
3
3 and -10.
3 and 10? Okay.
Well, no.
Oh, change your mind?
-10 and 3?
-10 and +3? -10 times +3 is -30. -10 plus 3 is -7. I need -1, so that's not going to work. How about -6 and +5? That seems like a promising combination. -6 times +5 is -30. That's a good sign. -6 plus -5, plus +5 is, Lord have mercy, -1. You did it. I'm so proud of you. I might start telling people I know you. Cool, so the numbers we want are -6 and +5. That's the pair that worked. What do we do with them? Well, we take this term in the middle and we break it apart into two things. So the 3x squared stays the same. The minus x becomes -6x plus 5x. How do we know -6x plus 5x? Because those were our two magic numbers that worked, -6 and +5. And then on the end, -10. Okay? I'm optimistic so far. Now what? Factor by grouping. So let's put the first two together. 3x is the GCF. So good. Gosh. What's left?
Divide.
Uh-huh.
Negative squared? No, so it'd be 1.
It'd just be x. X squared divided by x is x. So 1x minus 2. There we go. Yeah. Good. All right, let's group these two together. 5. Yeah, it starts with the positive, so +5.
X minus 2.
How about that? So good. I'll bet you know what the answer is. What goes out in front?
X minus 2.
X minus 2. And then the second set?
Plus 5.
And that is the answer. Yeah! Don't forget about the GCF of 2. That goes in the very front.
So how do you know when you use a negative factor out?
Oh, good question. The question was, how do you know when you factor out a negative? And the answer is, if it starts with a negative, factor out a negative. This started with a positive, +5, so we factored out a positive. If it starts with a negative, factor out a negative. Okay. Any questions on that one? I feel like it's been a really long time since I gave you just a life-ruining problem. So let's do that for old time's sake.
Save the worst for last? Or
I saved the worst for second to last. How's that? I'm just kidding. The next problem is way worse than this one. You know how math class works. They just get worse and worse and worse until somebody cries. That's how you know it's time to stop, when someone has a breakdown. I noticed the closer we get to the end of the semester, the faster the breakdowns seem to come. All right, what do we do first? Find the GCF if there is one. Is there one? Yes, there is. We know, we're suspicious immediately that there's a GCF because everything has a Y in it. So we know there's at least GCF of Y, but we can be a little greedier than that. They all don't have just a Y.
3.
They'll have at least Y squared. They'll have at least Y squared. And then someone said 3. 3 goes with the numbers. 18, 21, and 60 can all be divided by 3. So 3Y squared is our GCF. So 3Y squared What would be left in the parentheses if every single thing was divided by 3y squared? 6.
Squared.
Very good. 6y squared plus
7y.
7y. Good. Minus 20. Outstanding. Very good job. So don't forget, we have a GCF in this problem. Don't forget about him. But now let's check and see if what's left, 6y squared plus 7y minus 20, let's see if that can be factored. So what's A?
6.
6. B is 7. And C is?
Negative 2.
So I'm looking for factors of
120.
negative 120. Whew.
That's why you said this is the best problem.
Yeah, this one's pretty rough just because the numbers are big. I need two numbers that I can multiply together to get negative 120, but when I add them, I get 7. So what it tells me when I have such a big multiple and then the sum is so small, like multiply for negative 120 but add for only 7, what that tells me is my two numbers need to be close together. Something like negative 120 and 1 is not going to work because 120 and 1 is nowhere near 7. I need numbers that are really close together. Not too close together, though. Like 12 and 10 are really close together, but they're too close together. 12 and negative 10 would give me 2, so those are too close. So what's a factor of 120 that's like close to 10, but a little bit lower than 10? 5?
Yeah.
5 and what?
Yeah.
30.
So,
No.
14? Negative 25?
So 5 and what?
So, 100 divided by 5 is what?
20. 100 divided by 5 is 20.
Okay,
So 120 divided by 5 would be 24. So remember to get 7 from 5 and 24? Doesn't seem like they're too far apart. So we needed something lower than 10, but 5 is too much lower than 10. What's something in between 5 and 10?
8.
8? 8 and what? Could 120 even be divided by 8? 8 and 15. One of those would have to be negative, right? Because we need negative 120. So negative 8 times 15. That's negative 120. What's negative 8 plus 15? You are a genius. Nailed it. Cool. So the 7y is going to get split apart into minus 8y plus 15y. So 6y squared minus 8y plus 15y minus 20.
Wait.
Oh. Man, it's getting rough if you're already saying prayers over there. All right, let's group them. What's the greatest common factor of 6y squared and 8y? I like 2y. That seems good. What would that leave us with?
3y.
3y minus
4.
4. Very good. Then let's look at the next pair.
5.
Positive 5. It starts with a positive. Back out positive. That would leave us with 3y Oh my goodness. What are the odds? What are the odds? So what will be out in front?
3y minus 4.
3y minus 4. And what's left?
2y plus 5.
And that's the answer.
No, it's
3y
not.
Nope.
squared
We
and
forgot to see it.
Forgot about the GCF.
3y squared.
I screwed that up.
Don't worry if you mess up. I'm reminded the words of Abraham Lincoln, who once said, if you mess up at factoring, you can teach a man to fish.
It's just lovely.
Think about it. Okay, let's do one more.
House divided can stand.
Oh, that does sound more like Lincoln. Whew. That's a pretty good problem.
There's no GCF.
There's no GCF. You're right about that. So we're going to go straight into labeling A, B, and C. A is 4, B is 20, and C is outstanding. So I'm looking for factors of
100.
100. All right.
10.
Huh? What were the factors you got?
10 and 10.
10 times 10 is 100. I agree with that. What's 10 plus 10?
20.
Oh my gosh, it's 20. Providence. Wow, you're getting much faster at these now that you don't want to do them anymore. So we're going to take that 20x and we're going to split it into 10 and 10. So the 4x squared stays the same. The 20x becomes plus 10x plus 10x. And the 25 on the end is just 25. Now what? Now let's group them. Good idea. So you said 2x is the GCF there. I agree. That's pretty good. What am I left with in the parentheses if I take 2x out of everything?
2x plus 5.
Good. 2x plus 5. Outstanding. Okay, so what about these two? Greatest common factor of 5. It's a positive. Positive 5. What are we left with in parentheses when we divide by 5? 2x plus 5. Okay. So
2x plus 5.
the outside parentheses will be the 2x plus 5. That's the thing they both have in common. And the inside will be
2x plus 5.
2x plus 5. Huh. Can anybody think of a better way to write 2x plus 5 times 2x plus 5?
2 was on the outside parentheses. Like 2x plus 5? Or no, squared.
Wait, what?
Squared.
Now both of these last things are correct, but this one's a little better. This is more likely to impress people at your next math party, the 2x plus 5 squared. So that's the way I would prefer you
But
write
how
it.
did you get 2x plus 5 and 2x plus 5?
Well, that's a good question. She said, how did you get 2x plus 5s? The parentheses they had in common was 2x plus 5. That was one of them.
Okay.
And then the greatest common factors were a
okay.
2x and a plus 5. So this is what it looks like when the parentheses are the same.
Does that mean the problem was a perfect square?
It does mean the problem was a perfect square. The square root of 4x squared is 2x, and the square root of 25 was 5. So excellent observation. It was a perfect square.
Pain is real.
Does anybody have any questions about this kind of factoring? This would be a great time for you to ask them. If you have any questions, post them in the comments below and smash that like button. No, we're good on this?